Hi everyone. So I'm just about to start this session. Just waiting for the sky to clear out. As you can see, there are still some clouds, but as Clear Outside says, it should clear out in a few minutes. So just gonna have to wait a bit. I already aimed at the sun, but the visibility is still very poor because of these clouds, so we're just gonna have to wait a bit. This right here is the edge of the sun. You can see this prominence here. We lower the exposure and we can even see this active region here with these 3 sunspots. Let me try to fix the focus a bit. So all this blurriness, as you can see, is just because of these clouds, and once they clear out we'll have a better image, and then I'll start the imaging process. So currently I'm not even saving this data. It's just garbage data. My telescope is here. I've got these 2 fans blowing. I actually learned from my previous experience that I guess 2 is better than 1. So 1 is pointed directly at the scope because there's this cooling system which I installed at the front of the scope, and this helps to dissipate all the hot air that's coming out of this cooling system. And the other one is just aimed at the camera and the filter here. So here, this thing is the quark filter, Daystar quark, and this little knob here adjusted. So what's it actually doing is it's heating up the element inside, which is called an etalon. But if it gets too hot, then the temperature is not right, and then it gets out of tune, and then we won't be able to see all this cool data, cool prominences, and all these hydrogen clouds. So I'm blowing a fan on top of it because that way it stays, at a pretty decent temperature, like more like the ambient temperature, plus or minus a few degrees Celsius. So what I'm going to do, I'm going to do a time lapse of this area here. The sun has just come out of this huge cloud, and we can adjust the exposure here just to see this better. Sorry, it's kind of blocking my screen a bit, but my screen is just ultra wide, and I have to crop things to just get him inside this frame. So yeah, now we can actually see the sun here. Let's like this. So there are a few clouds left, but the whole western side is clear, and the wind is blowing from northwest to southeast. So that means that these clouds are gonna go that way, and then we're gonna have a clear sky. All right. So we have our scope in view. Now we'll try to work a bit about the focus. By the way, you can see here my camera temperature is 44 degrees, which is very good compared to yesterday. It was above 50, so this thing really helps. I think I'm having a bit of vibrations because of the fan, so I might just go outside and you know, just move it a bit further. Not sure if it's the wind, but I think it's these cables that are vibrating because of the fan. What's your opinion on this? By the way, if you have anything to say, then please write in the comments and I'll try to answer. Okay, so yeah, maybe I'll try to move the move this fan, move the other fan a bit further away. Yeah, I think we can even start the imaging process. Let's try to get a better focus. Oh, one thing I want to do before I start the imaging process is to get a better flat frame. So flat frames is just capturing an out of focus image of a pretty clear area of the sun, just so we can get all the dust mites and all the all the dust and particles that are on the sensor, and we want to remove them, and also some inconsistency in the field of the filter. As you can see, this side is a lot darker than this side. So with the flat frame, we can kind of average it out. Okay, so let me show you what I mean. So I'm going to take this out of focus. And now, as you can see, we see only those dust mites and the gradient of this filter. So if we take a flat frame and subtract it from the image, we'll get a better flattened field. And now we can go back in focus, and that should give us a way better image and a very clear image. So we don't see these dust particles anymore, and also the frame is a lot flatter, as you can see. So now we could go back to our beautiful sunspot here. I kind of want to capture the sunspot and this prominence here at the same time. Sorry, I think my connection got disconnected for a second. Anyway, as I said, I want to get this sunspot and this prominence both at the same time. So I'm gonna position them in the center of the frame, and then I'm gonna turn on the camera's this software's tracking, which is this thing, and now it's gonna track this sunspot here, and it will keep correcting the position of the mount to keep this inside our frame. And then we can start the imaging process. There we go. Okay, so now we're capturing frames at about 66 frames per second. We're taking 500 frames each time. I know 500 isn't a lot, and there are a lot of guys that will take thousands of frames, but because the sun is so active and constantly moving and changing, we need to be very fast when we take our frames. Thanks, Alan. Thank you for watching. In between frames, I can turn on this gamma here, and then, like, show a bit more contrast. But I can't use it while I'm imaging, because then I will miss out all this prominence, because this added contrast is just destroying the background the thing that is darker. So now we have our first few videos. We can stack them and see what we expect from the final video. So let's see. Okay, this is the first one. So visibility is still not best, but as you can see, it does get clearer and clearer as the time goes. It should be completely clear by 10:30. Okay, so this is sorted the frames by their quality from the sharpest to the least sharp. As you can see, the first one is the sharpest one, and the last one looks like a complete blur. Alright, now we're gonna add some alignment points, and we're gonna stack this 25% out of the best frames. Okay, and now we can go into Registacks or any other sharpening software, and we can sharpen the details. Let's see what we have here. Yeah, still very blurry, but it has potential. We need to wait until the sky is completely clear. I am using a very high focal length, so we need very stable skies to see the full potential of this. So yeah, still not as good as I wanted. We'll continue the imaging and see what we get. Try to give this a better anchor point, because I see that it keeps jumping from side to side. In the meantime, I can show you some of the things, some of the other things that I've imaged. So this one was one of the best skies that I had here. This is like the sharpest view of a sunspot that I ever managed to capture. I mean, it's still not the best quality this equipment can get, because again, I live near the ocean and the sky here are very turbulent, but it is still pretty amazing. Like, this thing is about the size of this thing, so just look at this, how it looks blurry, and look at this thing. We can compare them. So the other day I also had the opportunity to shoot Jupiter at a very rare occasion. I streamed the imaging session to my YouTube, but I didn't yet publish the final result. I don't know if I should, because it didn't came out as good as I wanted, because again, the sky was very bad, but I'm gonna show you what came out and you let me know. A second. Yeah, I have a phone call. Anyway, so this is the final result. Let me know what you think. So the cool thing about this is that there are 3 moons in this video, and also one of them is right on top of this, you know, the red storm. So this is Ganymede, this is Europa, and Io is just coming out from behind the shadow here, from behind Jupiter's shadow. So 2 moons are eclipsing Jupiter, and the other one is being eclipsed by Jupiter. Pretty neat, right? So I think I'm gonna try to process this a bit more and then I'll upload it. Yeah, it does look like it's out of focus, but it's actually in focus. It's just imagine this the sky as, you know, a couple of several layers of air. Every layer breaks the air in the different direction, and then just imagine these layers moving in different directions, like opposing directions, and that's what's happening to the image. So some parts of it will be more inside of the focus, and some parts will be more of the outside of the focus. Like, you know, if it's like if you're taking the focuser in and out all the time. So the best focal point is actually in the middle of this. But yeah, it does distort the view a lot. So that's why we do this the stacking procedure. So let's see if the last frames are better than the ones we had before. I think it's got improved a bit. Yeah, it did improve. Okay, so let's stack these 25% frames. Alright. Again, I'm using Registacks, but any software is okay. We can sharpen it even in Photoshop. It's not there isn't anything like special in this software. Just use it because it's fast. Alright, so way better, but still needs a lot more yeah, okay. So the sky does get a bit get more clear now. Let's try a different approach here. Okay, so that looks a lot better. We can also invert the image. This is something that I like to do. It creates like this very very cool 3D effect to the image. Let me know what you think about this. Yeah, I placed a fan. I mentioned this before. I placed two fans. One is to cool this filter here and the camera, and one is to cool. I have an active cooling system at the front of the scope that keeps exuding like hot air, and we have to blow it away so it won't, you know, it won't stay here and ruin the image even more. Okay, so I said I wanted to move this a bit to the side because I think that this cable moving because of the air is because of the fan is moving the image a bit, and that also kind of ruins it a bit. So let me go outside and try to move it a bit further. Okay, I moved it further, but now we have to keep track of this temperature here. See that we're not that the camera doesn't get any hotter than what it is. Let's clear it. I think there was a bird just flew through the frame. It's funny how common these things when a bird flies through your frame. I mean, I'm looking at such a small frame here, but still birds manage to, you know, just look at this thing. This is very, very small. Let me reduce the exposure. Okay, I'm at 0 exposure, like the lowest possible, and still the sun burns the image. The sun is about this big here. Okay. Some frames will be better than others. It's always like this. So even though I'm taking small videos, each of 500 frames, so each of these videos is gonna go and become just one frame out of the final video. But even those 500 frames themselves are creating, you know, better and worse images. So each stack, sorry, might be better than another or worse than another. So when I wanna, you know, do just one image or create a static image of the sun and not a time lapse, what I usually do to get the best result, I mean, a lot of guys just take one image or maybe 2, 3, and then take the best out of them. So what I do instead of it, I take, you know, all the videos that I captured for time lapse and then choose the best out of them. So that gives me a lot more, a lot bigger chance to find something that is very sharp compared to the rest. You can even create. You can even do another trick. So you create a video of a time lapse that is itself frames that were gotten with this software, stacked, each of them stacked from a video, and then create this video, then reinsert this video into the software, telling it to analyze and order them by quality, and then you can see which frame is the best, is the sharpest one, because the software knows how to define and how to decide which is the sharpest. So instead of trying to look look at this with your eyes and decide yourself. You can let the software decide for you. So you can see every now and then there's this few frames that are very sharp, and you can see very good details. Let's try to see if we are in the best possible focus. Okay, so now I've gotten out of focus. Now going back in. Yeah, I think this is the best possible focus here. Bring it back to the center and then continue. Oh, oops. Yeah, no, forgot to clear this thing. Okay, continuing the imaging process. Delete this one. Yeah, it is pretty hard to capture them and process them. There's so many parameters that can go wrong. You know, I mean, other than just a USB cable that is malfunctioning, which is what happens most of the time. Even today, it happens to me, and I had to. I mean, usually I do I have two extension cords of 25 meters. And one of them just stopped working. The camera just won't connect. So I connected all the camera that is outside, and it couldn't handle that much data. When I connected the camera to the other camera too, it just disconnected everything. So I had to run another cable outside, and that happens all the time. Because it's very hard to find a good cable that is 20 meters or 15 meters long, especially for USB 3. I can put a computer outside, but that also won't do because then the frame rate that I get here from remote accessing the computer will be very low, and I won't be able to focus this thing. You see how turbulent it is and how hard it is to see the details here. So doing this from remote desktop is just out of the questions. You won't be able to even manage to see anything to focus it. So we want high bit rate because you want fast frames per second to get as many frames as possible without the sound changing. And so that then you need to have your computer connected to the camera with USB 3, but then you can do a remote desktop, so you have to find a long cable, but then long cables of USB 3 are very fragile and they keep disconnecting. So you have to fight all these things together, and that's just one aspect. Not to mention about the tracking and clouds and all that. You can't just leave it and go away and come back later, because it might just hit a small cloud. The tracking here will lose tracking, and then the sun will get out of the frame, and that's it. So you have to constantly keep correcting things. Right, we're starting to see a better quality here. try to find the best frame out of all of these. Okay, so I think it's one of the mid ones. This one, for example. The stacking process, because when there isn't much contrast, the stacking software can track the features. Okay, so that was just one trial. Let's see if it did anything. I'll move it aside so I want to mix with the other frames. These are from a couple of weeks ago. Also came out pretty good. Okay, let's see this one. Okay, not that much better, but a bit better. Alright, yeah, no, it's not about the, it's not a USB-C, it's actually USB-B. It's type B. That's what connects to the cameras. But it's because it's USB 3, 3.0 or 3.1, which has a very high bit rate. And I mean, the maximum you can get with the USB 3 cable without any power, without being active USB cable, is about 5 meters. After that, you will have disconnections. So I have this, as I said, I have two active USB cables which are 20 meters long. I had more. I even had one that cost me about I think about $300. They are very expensive, these cables. So I had one that cost me about $300, and it also broke. Also started malfunctioning, and I just threw it away. They didn't even want to refund me. It broke up after about 2 months. Just stopped disconnecting. Start disconnecting all the time. So now I have a cheaper one, but it's just it's holding about a month or two, and then I need to rebuy another one. Okay, seeing a lot of turbulence now. There's also some wind, but I think it's mostly because of the moisture in the atmosphere that we get these diffractions here. With a good polar alignment, you don't need that much corrections. But this is like the scope focal length is 2000, and this this filter here is a 4.3 Barlow. So that means 2000 times 4.3. Let's do a quick calculations to what's the active focal length. That's 8,600 millimeters of focal length. That's huge. So because of that, each small movement is causing this thing to get out of frame. So that's why I have to keep correcting. Right. So there are actually a couple of cooling systems. One is just these fans. This cable goes inside inside the scope, and there's one fan that is pushing air from here, and one on the other side, which you can't see from here, that is pulling air. So it's like creating this circulation of air inside the scope behind the mirror. So that's one. Another one is here, which is another small fan on top of a Peltier, which also actively cools the secondary mirror. And those two fans outside blowing cold air on top of the scope. And inside here we have an IR UV cut filter, which just pushes back all the IR and UV rays from the sun, which we don't need to capture this image. And there's of course the blocking filter of the quark itself, which sits as it, which blocks about 99.9% of the sun. Yep. Okay. Let me just yeah. So as we can see, the movement of the cables has dropped now. It's almost stable, but we still get some turbulence because there are still clouds. Yes, these are just light clouds, like, you know, just moisture in the air that is distorting the view a bit. Cold and hot air getting mixed together. There's always you know, you always need to compensate for this with either getting, you know, faster frames and then stacking, or you know, getting slower frames but with lower gain and then get less noise, and then you're gonna need less frames to stack. But then you have to be a lot more lucky to get, good frames with lucky imaging. So I usually do the first option, try to get as fast as possible, as much frames as possible in the shortest amount of time. That means high gain, so I have a lot of noise in my images, but that is not too bad when you are doing video time-lapse, because when you're watching a video the noise keeps moving, and because it's random noise, so you actually don't really see it that much. You don't notice it that much, that's what I mean, because it's moving. So in a static image the noise is very visible, but when it's moving it's a lot less visible. Okay, so let's see what we have here. This one is the last frame that I took, the last video which I stacked into one frame. Let's try to, yeah, let's do this thing again. I'm gonna just invert the image. So not as clear as I wanted for today, because this would have been very nice to see this thing in high resolution, but there's nothing I can do because the conditions just aren't right. So I think next time I'll try to drive to somewhere where the air is more dry, like maybe near Jerusalem or something like that. The aperture is 8-inch. It's an 8-inch celestron telescope. Yeah, no, it's not the outside of the telescope that is heating. I mean, because the telescope is pointing directly at the sun, so all the sunlight comes directly from this direction. So no sunlight is hitting it on the sides. So the thing that heats the telescope up is just the energy from the sun coming in from here, focusing on the secondary mirror, and then focusing back here. And if I put it in a canopy, it won't help because the light from the outside doesn't do anything. But it's enough to keep the air moving. I mean, that's why I put these fans. When the air is sitting still, then it can heat up very, very fast. But when it's moving, then not so much. And anyway, the turbulence that we see in the image, what ruins our image is not from the hot air from here. It's more from hot and cold air on the topper parts of the atmosphere. It's not even if there are clouds, then the clouds can ruin this, but mostly it's above the clouds. It's just the visibility of the sky. I think I might need more than 500 frames. I think this is why it's not getting as clear as I wanted. Let's try just for once, limiting this to 1000 frames instead of 500, and see what's gonna happen. So it takes about 15 seconds for 1000 frames, and before it took half of that. So I'm gonna reduce the delay between the frames from 30 seconds to I guess 22 seconds, just to compensate for this additional time that it takes to save 1,000 frames instead of 500 frames, so the outcome video won't be affected. Okay, so let's see what 1,000 frame stack looks like. Hopefully it will give a better result. So as we can see now, the size of the video has doubled, of course, from 2.3 gigabytes to 4.6 gigabyte for each video. Hopefully I won't run out of space. I have another 600 gigabytes, so I think we're gonna be okay. Okay, let's, yeah, okay, the software has crashed. Let's reopen it. Right. So 1,000 frames might be more blurry because it took more time, but it might, you know, find sharper frames than a 500 frame stack, and this might works to our best. So let's see. And you can save this image and then compare them. Let's save this one. And now we have another one, and let's compare them. I'll do the same process to both of them, same parameters. Okay, I think this looks a bit better, so it means I can sharpen it a bit more without ruining it. So yeah, this is the first and this is the second. This looks a lot less noisy, but also less sharp, I guess. Okay, it's worth a shot. Try to push the sharpening a bit more. Yeah, alright. I think this is a lot better. Yeah, I think I like this one better. So let's keep it 1,000 frames. I can also do another thing. I can reduce the gain, and with higher exposure get, you know, get less noise. So less noise means I can sharpen the image more without ruining it. Okay, so I think I'm gonna wrap this thing out now. Yeah, it is ZW174. I think I'm gonna wrap this live broadcast up now. I don't. I also don't see a lot of interest in this live streaming of solar imaging. But I guess the final result is worth it. So I'm gonna leave this now, and hopefully today, maybe tomorrow, I'm gonna post the final result. I really hope this thing. I really hope the sky will clear up a bit more, because if we can get high resolution images of this thing, it's gonna be really amazing. So anyway, thank you all for watching, and hopefully I'll see you in my next videos. Thank you, bye bye.